So correct me if I'm wrong, but I think that yesterday, or did we yesterday, this is the wrong sheet, I need this sheet. Did you guys do this one? We did not do this one. That's right. Y'all did NaClO and SO3, the last two, correct? All right. So let's jump on board right here. So this is the first one we're going to work on. So let's just follow the rules just like we did yesterday. So rule number 1: determine if the compound is neutral or charged. And again, just like yesterday, look for the positive or negative. So what is this one? Neutral. So what are we setting this equal to? 0. Very good. So I'm going to put a 0 there and just kind of cross it off. Everybody good with that, right? That's a good question. If I left it as without the cross, it looks like oxygen. And we use oxygen so much, I never want you to say, is that an O or is that a 0? So that's why I've just kind of gotten in that habit. All right, number 2. Atoms by themselves are 0. Is anything by itself? Nope. Move on. This is a new one. This is the step that I went in and added. Step number 3. Do you see parentheses? No. So if you did, I just want to read real quick what you would do. You would distribute the subscript outside of the parentheses to the elements, and this is the important part. Read this aloud with me. To the elements where? Only inside the parentheses. And when we get to one of those problems, it will make more sense. But that's one of the steps I went in and added. All right, step 4. Is it an ionic compound? So it's the first element of metal. Yes. Who is it? Iron. Well, here's the problem. If it's a metal, the oxidation number comes from the charge. Well, what group is iron in? And that's a trick question. It's a transition metal. We'll read that little second bullet that's all in green. It says transition metal must reverse crisscross and check the charges. So here's the deal. I'm just going to I'm going to do it over here actually. So we've got Fe2O3. If I reverse crisscross, I've got a 3 plus and a 2 minus. That's the first part. So is that right or wrong? Right. Very good. So I'm going to put that down so I know that's 3 plus. Everybody okay with that? All right. Step number 5. Fluorine always. Do I need it? Nope. Step 6. Oxygen usually. Do I need it? Yep. And what is it? -2. What's the best news about this problem? You're done. Now, just to prove to yourself that this does work and you are finished, what is +3 times 2? +6. What is -2 times 3? Does that equal 0? Then you did it right. That's just one of the... So some of these are a little easier because you don't have to do any of the other math, but that is kind of a rare one. So any questions on that? Does that make you okay? All right. So now I'm going to do 2 more side by side. Nope, I'm going to hold off on this one. So, first question, is it neutral or is it charged? Neutral. What do I set it equal to? Second question, elements by themselves are? Exactly. Read step number 2. Atoms in pure elemental form have an oxidation number of 0. They are by themselves. No other elements are attached. So what is the oxidation number of this thing? 0. Very good. Now, let me throw 2 things at you. This is a different problem. What if it were O2? What if it were P4? And what if it were S8? My first question, are any of them charged? So they're all set equal to. Is there anything else there with them? So what are all the oxidation numbers? You do. They're all zeros. They're all by themselves. Yes, no? All right. Very good. There's nothing there to share their electrons with. There's no other elements. Okay? All right. Now, let's do this one as a group. Now, conserve your space here, guys, because we're going to need a little bit of space on this one. Right off the bat, how's this one a tiny bit different? You got parentheses. Now I'm going to throw this curveball at you. It's not for any points, but in your brain, please don't say this out loud. Can you name that thing? What's the first word? Magnesium. The part that you guys don't know, what'd you say? No, the first word. Magnesium. What's the polyatomic? Hypochlorite. So that's magnesium hypochlorite. All right, so that's completely separate. Number 1, equal or charged? Wow. Neutral or charged? Neutral. Set it equal to 0. Step 2. Is anything by itself? Yes, ma'am. Yes. Number 2, anything by itself? No, you've already answered that. Step 3, this is the important part. Do you see parentheses? Yes. Now, this is the part that every year I have students do it 2 ways. And let me tell you, and again, remember how I drew half arrows and I told you the crisscross method? I'm telling you that the best way to do this is probably the way I'm going to show you. And I have students do it 2 ways. Some of them get it right all the time, and some of them have some issues with it. So I'm going to show you the way that I would do it. In the rules, it says distribute the subscript. Now, first of all, what is the subscript? 2, outside of the parentheses to the elements where? Only inside. This is just like math class, right? If this were a full math problem, anything outside the parentheses you don't touch, right? It's only going to be effective. So here's what I want you to do. Underneath this, I want you to rewrite it. Mg, and what would it be written as? Cl2O2. Rewrite it just like that. Now, does it change everything? Yes, but I don't care about the name at this point. I don't care about the mass at this point. I just want to know what the oxidation numbers are. And what this does is this allows you to see the elements as they are, not with all those parentheses and you having to mentally do it. Again, this is just like writing the charges and crisscrossing them. You can see it better than having to leave it as it is written, right? So this is the example that we're going to work with. So now I'm going to do it on both of them so you can see the differences of why I encourage you to do it this way. So let's move on to step number 4. Is it an ionic compound? Is the first element a metal? Yes. Who is that? What group is magnesium in? Group 2, so I'm going to do it here. So +2 and +2. I'm going to work them both at the same time. Next question, fluorine. Don't need it. Number 6, oxygen usually. Yes. What is oxygen in this case? -2. So I've got a -2 here and a -2 here. Number 7, hydrogen has an oxidation number of, I don't need it. Yes, ma'am. Yes, ma'am. Okay. And then number 8. This is a new one as well. We haven't seen this one yet, so let's read this one together. Are there 2 or more elements left without an oxidation number? No. So do I need that rule? Nope. So let's move on. We just need to figure out chlorine. Everybody with me? All right, so now let's do our math. Are y'all with me? Okay, so I'm going to bring this down. What is +2 times 1? +2, very good. So I've got a +2 here. I've got a +2 here. Now, this is where it gets to be easier in my method. Again, this is my method, okay? What is -2 times 2? So that we know that's a -4 there, and we know that this is a -4 here. Oh, I forgot this. This is also equal to 0. I forgot that. Yes. Yes. Now, we now know that we've got to find the number for chlorine, correct? Basic math tells me I've got 2 positives, I've got 4 negatives. I need it to equal 0. So what do I need? 2 what? Positives. I need a +2 here and a +2 here. Now, you can probably see why students miss this, because here's what happens. Look at the top version. I'll draw a line between these two. If you do not distribute, what does it look like you're dividing by right here? A 1. So what would you possibly put up top? A 2. But the problem is, what do you really have to divide by? Now do you see why this is a little easier? Your brain can separate those things out, because if you forget to bring this 2 over here, you're going to mess everything up. So what is 2 divided by 2? 1. So your final answer is +1. Does that make sense? Okay. So when you distribute, it makes the numbers look a little easier to deal with. Let's look at another example. Yes, ma'am. Yes, ma'am. Yes, ma'am. Okay. Do you agree that I had to divide 2 divided by 2? That's 1. Does that make sense? Just like here, if I said negative 4 divided by 2 is negative 2, and then positive 2 divided by 1 is positive 2. So basically, you can take any of them and divide them up and it should equal, or you can multiply them down, it should equal. So positive 1 times 2 is positive 2. It works both ways. Yes, absolutely. And in fact, that's a really good way to think about it. It's an answer check system. All right, so let's look at this one. We've got CuNO3 2. So step number 1, neutral or charged? Neutral. Set it equal to 0. Is anything by itself? Nope. Step 3, do you see parentheses? What are you going to do? Break it down, distribute it. Very good. So I'm going to rewrite this as Cu in what? 2O6. Very good. Cu in 2O6. Is it still equal to 0? Yes, very good. Still equal to 0. Now let's go to our next question. This is question number 4. Is it an ionic compound? Do you see a metal? Yes. Who is that metal? Copper. Well, there's a problem. Copper's in that funky group. What group? Transition metals. How do you figure it out? Reverse crisscross. So if I write CuNO3 2 over here, I get a 2 plus and a 1 minus. So not only reverse, but also check. Do you get a check on that? Yes. So what's copper's oxidation number? 2 plus. Everybody with me on that? I don't want to go any farther unless you're with me with that. Yes, ma'am. Yes. That's a great question. Don't pull the 6 up. Yeah, I agree with you. Don't do it with this version because this is just for math. This is the actual compound. Stick with the actual compound. Okay? All right, now let's move on with our next one. Step 5 says fluorine. Don't need it. Step 6 says oxygen. I do have that, so oxygen's what? Negative 2. And then I'm left with nitrogen. So I've got to figure out what nitrogen's going to be. All right? So bring our math down. What's positive 2 times 1? Positive 2. What is negative 2 times 6? Negative 12. Now, again, if you just know some basic math, I've got 2 positives and 12 negatives. I got to make it 0. What do I need? 10. Very good. I need positive 10. If you left it originally like I wrote it, you would want to divide it by 1, but you can't. You've got to remember that 2 distributes to it, so the answer should be what? Positive 5. It does. 2 plus 10 is 12. 12 minus 12 is 0. How did I get 5? So good. 10 divided by 2 is 5. Now, Bailey, if that 2 did not exist, like if it were a different problem and that 2 disappeared, it would be 10. If it were 3, well, that's a bad question. If it were 5, the answer would be 2. Does that make sense? Like, if this were a 5 right there, the answer would have been 2. All right. Now, I'm going to give you one on your own, and I'm going to go ahead and tell you this is going to be tricky. If you get this, you understand this very well. I'm telling you there's a trick built into this one. Don't let it get you. So it's like I told you, there was a trick built into this thing, and here's how I can alleviate that trick, is if we name it. You first know that it's iron, right? Now, here's the problem you all have. What is this thing? Sulfite. Well, if you wrote that on a test, would you be right or wrong? Wrong. What's missing in the middle of those two words? Your Roman numeral. So here's the deal. Again, you have to recognize that technically there are some parentheses that are surrounding and protecting that thing. Some of you want to take the 3, but if you take the 3, do you destroy the polyatomic? Yes, you can't take the 3. So what's technically back there? A 1. So I'm going to rewrite it over here. So I've got FeSO3. So it's 1 plus and 1 minus. And on your rule sheet, it says reverse crisscross and check the charges. And here's another part that you guys have trouble with. Is that right for sulfite? No. What is sulfite? Very good. It's 2. So this turns from 2. That turns to 2 negative and 2 positive. So now we know which iron it is. The whole polyatomic is 2. Sulfite is 2 negative. Massimo, does that make sense? I tell you what. Let's do it again. So if I do it like this, you with me? If I take whatever number is back here and pull it up, that's a 1 plus. If I take this and I pull it back, that's a 1 minus. So what I'm telling you is this whole thing is negative 1. Does that make more sense? Now seeing it a little bit bigger. The parentheses do help. I agree. And like I said, I'm not opposed to putting them in parentheses, but you just won't always see it that way. So I need your mind to get adjusted to it. So now we know that iron is a 2 plus. We know that oxygen by itself is what? Negative 2. Set this thing equal to 0. And what are we solving for? Solving for sulfur. So I bring down a plus 2 here. What am I bringing down with oxygen? Negative 6. Well, that's easy. What you got to have? I got to have plus 4. Do I have to divide by anything? Nope. So it's going to be plus 4. Okay. Now that you've seen it, it should make a little bit more sense. See if I can give you one more. Yep, I got one more for you. This one's going to be a little bit more straightforward. The only way to get good at this, just like naming compounds, is to practice it. Let me give you one little piece of advice. We've already done this one? Okay, my bad. Sorry, I didn't know we did this one yesterday. All right, completely changing gears. All right, so let's do this one. CHCl3. This one's really good. It's not on... Say again. We're going to get there. Hold that thought. I promise I got a rule for you. All right, rule number 1. I don't even know what I did with my sheet. All right, rule number 1. Determine if the compound is neutral or charged. Neutral. Set it equal to 0. Rule number 2. Anything by itself. Nope. Rule 3. Do you see parentheses? Nope. Rule 4. Is it ionic? No. What do you not see? You don't see a metal. So we're going to move on. Number 5. Do you see fluorine? Number 6. Do you see oxygen? Number 7. Do you see hydrogen? Finally, we have a rule. Hydrogen has an oxidation number of +1 in compounds containing elements that are more electronegative than it. Listen to the exception. When hydrogen is with a metal, can I stop right there and quit reading? Why? There's no metal, so I don't even need to keep reading that. So hydrogen then tells me it is a +1. And this is why I went back and reprinted your sheets. The first rule I added was the parentheses. This is the second rule. Are there 2 or more elements left without an oxidation number? Yes. That's your rule, Robin, that you didn't know yesterday that I went back and added, okay? So I told you I got a rule for you. So here's what you do. It says what in blue and bold? The more electronegative element gets its charge from its group number. Of the 2 that are remaining, carbon and chlorine, who's more electronegative? Chlorine. And chlorine is in what group? 17, and so its charge is -1. Now we're down to one that we have to solve for. So I have you a rule. That's why I reprinted this sheet for this exact reason. Now it's just basic math again. I've got plus 1. I've got negative 1 times 3 is negative 3. Why not write 2? So, you tell me what goes in that blank. Very good. Positive 2. Is there anything that I need to divide by? Nope. So I've got positive 2 is my final answer. Is that good? All right, let me let you try one just like that. Little mini quiz. Can you name that? Don't answer it. In your brain. Ammonium chloride. Yep. Yes, sir. Let's go to the rules. First question, neutral or charged? Neutral. Set it equal to 0. Nothing's by itself. Is it ionic? Well, actually, I forgot a step. Do you see parentheses? No. Is it ionic? No. Do I have fluorine? Do I have oxygen? Do I have hydrogen? Yes. Is hydrogen with a metal? So it's plus 1. Now we run into this issue. And this is what I was going to show you, but I decided to back off. And let me show you now. So if you're doing this, we need to determine which one is more electronegative. So here's the question. How do you really determine who's more electronegative? Closer to fluorine. Now let me ask you something. Now this is going way back. In terms of nitrogen, oxygen, and fluorine versus phosphorus, sulfur, and chlorine, which group, the top row or the second row, is the smallest? The top row. Because remember, it's got less orbitals, so it's a little bit smaller. Remember Zeph? Okay. So what's happening is those are actually a little smaller, so sometimes they're a little bit more powerful. However, if you look at nitrogen right here, it says the electronegativity of nitrogen is 3.04, and then it says chlorine is 3.16. So it, in fact, does prove that chlorine's more electronegative. So then chlorine gets its group number, so which is -1. So we've got -1. So I'm going to bring this down to be +4. Bring this down to be -1. And so what does nitrogen get? -3. So what am I dividing by? So there's your answer. Everybody okay with that? Alright, so here's what I'm going to do. I'd actually had a second thing I wanted to cover, but what I'm going to do is I'm going to go ahead and let you guys start working on your homework. You got 15 minutes, actually 20 minutes to work on it. So I'm going to stop the video and go ahead and give it to you.